Today in Capechi's Corner, we're going to complete some review problems on linear inequalities. In our first problem, we're going to solve and graph. So the first thing I want to do is I want to get x by itself, so I'm going to draw my wall. I'm going to subtract 7 from each side, so I'm left with negative 3x is greater than 36. I'm going to divide both sides by negative 3. Now when I divide by a negative number, remember I got to change the direction of the sign. So I'm left with x is less than negative 12. So when I graph it, I have 0 here, negative 12 is somewhere down here, and so I have an open circle to the left. We have a similar type problem in our next problem. So again, there's my wall. I want to get b by itself, so the first thing I'm going to do is I'm going to distribute. So I have negative 8b minus 2. On the right-hand side, I have negative 3b plus 8. So I want to bring my variables to one side, so I'm going to add 3b to both sides. And I'm left with negative 5b minus 2 is less than 8. I'll add 2 to both sides. I have negative 5b is less than 10. Now again, I'm going to divide by a negative number, so I need to change the direction of the sign. So I have b is greater than negative 2. So I'll put 0 here, and negative 2 is here, and I have open circle to the right. In our next problem, we're actually going to solve a compound inequality, which means we have more than one thing going on at once. So we have two inequality symbols, so I'm going to draw my wall at each of them. I want to get the c in the center by itself. So first I'm going to subtract 4 from each of the sections, and I have negative 7 is less than or equal to 7c, which is less than 14. Now I'll divide everything by 7. So I'm left with negative 1 is less than or equal to c, which is less than 2. Now my graph I'll spread it out a little bit, so let's make my negative 1 here, I'll make 0 here and 2 there. So negative 1 has a closed circle on top, it's including negative 1. 2 is an open circle, so my solution set is between negative 1 and including negative 1, and it's also less than 2, but not including the value of 2. Our next inequality has an OR statement, so we have to be careful of that. So I'm going to solve the two inequality statements separately. So I have negative 2m plus 7 is greater than 13. So I'll subtract 7, and I'm left with negative 2m is greater than 6. Divide both sides by negative 2, change the direction of the sign, and I have m is less than negative 3. Now I have another part of that, so I have 5m plus 12 is greater than 37. I'll subtract 12 from either side, and I have 5m is greater than 25. Divide both sides by 5, and m is greater than 5. So my solution set includes all numbers that are less than 3, and they also include all numbers that are greater than 5. It's one or the other. So on my graph, I have negative 3 is here. I'll make 0 here and 5 up here. So I have open circle above negative 3 to the left, and then I have open circle above 5 to the right. Our next problem is actually giving us the graph and asking us to write the inequality. So I noticed that in the graph for A, I'm including values that are between two numbers, so that's going to be an and. So I have negative 1, and I have x in the center, and I have 4 here, because they're the values that are marked on my number line. At both values, we have a closed circle, so that's going to be less than or equal to. So I have negative 1 is less than or equal to x, which is also less than or equal to 4. In letter B, we have arrows going in opposite directions, so that's an OR. So the first part here is x is less than 0, or I can also say that x is greater than or equal to 3. In our next problem, we're going to solve and graph the inequality. So I need to make sure the absolute value symbol is by itself, which it is when I draw my line at my absolute value symbol. So now I can split it into two separate inequalities. Remember, when we have an absolute value, we're always going to have two different answers. So I have negative 3p minus 7 is greater than 5. And then my other side is going to say negative 3p minus 7. I'm going to change the direction of the sign and make that 5 a negative 5. So when I go back to my first, I'm going to isolate my letter p. So I have negative 3p is greater than 12. Divide both sides by negative 3. P is less than negative 4. Now this is greater than, greater, so that's going to give us an OR. So when I solve my other inequality, I'm going to add 7 to both sides. And I have negative 3p is less than 2. I'm going to divide both sides by negative 3. And because I'm dividing by a negative number, I'm going to change the direction of the sign. So I have p is greater than negative 2/3. So when I graph it, I have -4 is here, 0 is here, -2/3 is pretty close to 0. So I have an open circle to the left, and then I have another open circle to the right. In our next inequality, I notice again that we have an absolute value symbol, so I need to isolate that. So there's my wall. I need to add 7 to both sides. So I have the absolute value of 4x minus 5 is less than or equal to 39. Now, because I only have my absolute value symbol now on one side of the inequality, I can split it. So my first inequality is going to say 4x minus 5 is less than or equal to 39. Now this is less than, so that's an and. And then I have 4x minus 5 is greater than or equal to -39. So back to my first inequality, I'm going to solve it. Add 5 to both sides, and I have 4x is less than or equal to 44. Divide both sides by 4, and I have x is less than or equal to 11. Work on my other inequality. I'm going to add 5 to both sides, and I have 4x is greater than or equal to -34. Divide both sides by 4, and I have x is greater than or equal to -8.5. Now I need to rewrite that statement as a compound form. So I'm going to have -8.5 is on the left. I have my x is here, and then my 11 is on the right-hand side. If I'm looking at this inequality, my arrows will stay pointing to the -8.5. I look at my x is less than or equal to 11. It's pointing to the x. So there is my inequality there. So if I go back to my graph, I have -8.5 is here. 0 will make 11 somewhere up there. So I have a closed circle above both, and I'm including -8.5 and 11 and all the values that are between them. Now in the next problem, we're going to graph the inequality on a coordinate plane. So the first thing I want to do is I want to get y by itself, so I'm going to add 19 to both sides, and I have 4y is less than 20. Divide both sides by 4, I have y is less than 5. Now that's a hoy, so that tells me that I have a horizontal line wherever y is equal to 5. So I have a less than, so that's a dashed line. So I'm going to go to my graph, and wherever I find 5, I'm going to put a dashed line. And then I have less than, so I'm going to shade below. So my solution set is all the values are in that shaded region. I'm going to do some more graphing. So again, here's my wall. I need to get y by itself, so I'm going to subtract x from either side. So I have -y is less than or equal to -x plus 4. Divide everything by -1. Now I divided by a negative number, so I'm going to change the direction of the sign. So I have y is greater than or equal to x minus 4. So my y-intercept is -4, and my slope is the coefficient before y, which is 1, so I have 1 over 1. So because my numerator is positive, I'm going to go up 1. Because my denominator is positive, I'm going to go to the right one. Now we're ready to graph. So my y-intercept is -4. I'm going to go up 1 to the right one, up 1 to the right one. I'm going to do several points. Now back in my original inequality, I had less than or equal to, so that's going to be a solid line. So I'll take a solid line right through my points, and then I will draw an arrow on the end. And when I look at my final inequality, it says greater than or equal to, so I know my values are going to be above the line, so I'm going to shade. Now another way, if I just want to double check to make sure I did that correctly, I can pick a point that's inside that shaded region, which is 0, 0, and that can be my test point. So I'm going to go back to my original inequality, and I'll substitute that in. So everywhere I see an x, I'm going to put a 0, same thing with the y. So I have 0 is less than or equal to 4, which is true. So that does mean that wherever 0, 0 is, that is the side that is part of the solution set. So therefore, that's the side that I should shade. Now in our last problem for today, we have a word problem. It says the Addams family wanted to take their neighbors to the movies. They won $200 in the lottery and wanted to have a fun night. They found a great discounted movie theater that charged $6 for children, which is going to be X, and $10 for adults, which is Y. Now, I noticed that I'm going to have to graph. So our x-axis, it tells us our children. So I'm going to label that. So it's going to be the number of children that are going to be able to go to the movies. And our y-axis is the number of adults. So I will label that as well. Now, part A says write an inequality for the given scenario. So I noticed that it costs $6 for children. So I'm going to make that 6x, $6 per each child. And I also would have to pay $10 for each adult. Now they have $200 that they're willing to spend, which is very nice of them. So that's less than or equal to 200. So I can spend up to 200 or less than that, but 200 is my limit. So I'm going to graph it. So I want to get y by itself. So in part B it says graph the given inequality. Remember to label your axis, which we already did. So I'm going to get my y by itself so I can graph it in slope-intercept form. So now I will divide everything by 10. And I have y is less than or equal to, now negative 6 over 10 simplifies to negative 3 over 5x plus 20. Now I know my y-intercept is 20, and if you look on the graph, I realize this is going to be a little bit difficult to do by ones because of the size of the graph that I have. So I counted by twos. So I'm going to start at 20, which is up here. My slope is negative 3 over 5, so I can still go down 3, 1, 2, 3, to the right 1, 2, 3, 4, 5. There's my point. Down 1, 2, 3, to the right 1, 2, 3, 4, 5. There's my other point. I have a less than or equal to sign, so I can use a solid line here. And then it says less than or equal to, so I know I'm shading below. So I'm going to shade below. So my solution set is anything in the shaded region. Now if I look, so this is part B right here. If I look at part C, it says how many total adults and children can go to the movies. So there's a lot of different combinations I can use. Anything inside that shaded region is a solution set, so it will work. So I could say, for instance here, I can say 8 children. I could say 8 children and 4 adults because I counted by 2. If I wanted to, I could go up here somewhere, and that would be 6 children. And that looks like it's 14 adults. So really any combination within that shaded region, they'll have enough money to pay for.